Welcome to an AHB webinar, ladies and gentlemen. My name is Mark Bantilan. I'm the marketing manager of AHB.ai. We'll be commencing our webinar presentation shortly, so feel free to grab a cup of coffee while you wait. Please share the stream with your family, friends, and colleagues as well. And if you have any questions during the presentation, please feel free to submit them in the Q&A tab, and we'll address them during the allocated Q&A session. To provide you with a brief background about our company, we are AHB.ai, which stands for Hathboor Bikal.ai. We are a joint venture between Hathboor Group, based in the UAE, and Bikal Tech UK, based in the UK. We are a technology company that utilizes AI and 5G technology to assist both the public and private sectors in enhancing their processes and solutions. Today's presentation is titled Unlocking the Power of HPC Data Centers and Technology Transfer. Our speaker for today, a seasoned industry veteran with over 2 decades of experience, is a staunch advocate for technology transfer in the universities and the public sector, and a firm believer in the value of university research. He is the GM, CEO, and lead business scientist of Hathboor Bikal.ai and Bikal Tech UK. Please join me in welcoming Mr. Raj Sandhu.
Thank you for everybody for joining the session. The idea of today is to basically just give you an overview and an oversight as to what the work that we are doing in general and how that could potentially impact things that you're doing in your enterprises, whether it be big or small, whether it be private or public sector. So, as Mark mentioned, obviously we are a joint venture between a local company, Hathboor Group, who are out of Dubai, and obviously Bikal, which is based in Coventry, UK. I'm actually talking now from Sharjah, from the Sharjah Research, Technology and Innovation Park. So this is an ecosystem. We're part of an ecosystem where there's obviously universities that are based around us. I think there's 20-something universities, and obviously even within the UAE, we communicate with universities from Dubai, Abu Dhabi, even Ras Al Khaimah, and Ajman. So the idea is that whatever we set up, obviously this particular talk is obviously regarding a data center that we have based at the park. Wherever we set up, we always look for that university involvement, not necessarily for that university to be producing research themselves, but at least they can localize any research that we may bring from the UK. Okay, so that's generally our sort of methodology, and obviously Hathboor Bikal. Now, we also have essentially a data center, a high-performance compute data center that is located in the Sharjah Research Park, which consists of 64 A100 GPUs, right? So these GPUs are very important when it comes to being able to develop, to be able to model and then develop product that has come from universities' research. And the data center itself is water cooled, as it states there. Obviously, we plan to make partially solar powered. So then the sustainability part is important as well. With any experimentation, you're not always going to get a success when it comes to technology transfer. So it's important to reduce the amount of power or footprint that you leave behind for things that don't necessarily tend out to be usable in the real world. So again, our sort of plan is, engaging with the university, we've got to bring something, if you like, to the table. And part of that is to make sure that we have the infrastructure to be able to do that technology transfer as well. In most cases, when it comes to the data center itself, the softwares that will sit on there, which I'll discuss in a bit more detail later, are also part and parcel of what the high performance computer is going to enable inventors or researchers or commercialized people to be able to use as well. So the level of software that we have to have is in tune with what the high performance stack is capable of doing. All right. So this is, let's say again, in terms of the data center itself, it's it's very agile in terms of its use, and again, it's built for tech transfer, which basically means it's agile and it's able to, be used as and when it's needed. A lot of universities, they do sometimes suffer from either aged high performance compute. So the way that we've constructed ours is that it's very interchangeable with the latest processors. And also with the software, and no one's, not one university's committed to it. We can do it across across a number of universities, and obviously across a number of different faculties, if you like, different subject areas. Okay, fair amount of compute power, 3.2 should be petaflops, I think it is, and we've got over 3.2 petabytes of storage. So you can do everything from obviously small metadata that might be in 5 or 10 GB or your MB through to genomes. That might I think the genome per person is like 90 gigabytes a person. So again, if you have a population of 5,000-10,000, we've got the storage that enables the analysis to happen. So again, can't reiterate enough, a high performance compute is needed for tech transfer. Okay, the one advantage we have obviously with the UAE is that the data sits within the UAE. So again, as I mentioned, some of the healthcare data, you can't really transfer that out onto a public cloud in another country. So that's one reason why we do put data centers in localities where we're located for technology transfer, because the data is obviously part of the value that is being put into the product development that comes out of tech transfer. A lot of, even if you're going to create synthetic data, even synthetic data is based on use cases, right, or some sort of knowledge of how something works in a particular country. So even that can sometimes be a bit sensitive. So again, having it within the country is a lot more effective for data governance and compliance. Okay, so we've got a number of use cases, which is probably reserved for another time. But basically, what we're trying to give you an example of is that we do everything across the board. Some of that is in-house product development, where we might have some expertise, but some of it is going to be external, where we don't have expertise, but we can definitely facilitate that technology transfer process. And that might be anything from a commercial model, but more importantly about today is about how do you actually code, or how do you actually develop a product by modeling it on a high performance compute, so that where that product could go and minimize the risks behind it as well. So even like it's written here, even predicting sandstorms and how that would affect a particular materials, you can do that down to the nth degree, as long as you've got the data for the environment, you've got the data for the actual building itself. You can then create materials from the high performance compute. And you can model, like I said, the good thing is where you can model many times over and find out what the optimal technology would be. Okay, so again, this is a little bit of information about using Mahed. Mahed is the name that we've assigned to the actual data center itself. But again, it's meant to be agile. And again, we do get involved with the tech transfer side, even if it's just advisory, just helping somebody out in terms of turning their idea into an actual product. Okay, the idea behind this is that we would have edge, high performance compute. So again, one of the things that we are trying to do is work on putting an edge in different parts of the world, because then obviously again your tech transfer product can go to another country more easily, but also it can gain foreground IP by learning on a different model or a different scenario of the same case. Okay, so moving on to what is tech transfer itself, right? So tech transfer usually starts off with a sort of research paper like this, right? Effects of natural weathering on solar panels is a good example, right? So you've got some very clever academics. You've got obviously the university located here as well, and so they will have written a paper stating that they found a new way or an innovative way of how to change, a paint surface so that the solar panel will last for a longer time. A lot of this will be done in theory. There'll be some testing that would have happened. again within the university, let's say grounds, it could have happened, and obviously then the paper is cited by other individuals or other companies to see if it's obviously got credibility. So that process itself, that research process, could be anything from 1 year to maybe 10 years in some cases, right? So along the way, the academics obviously want to publish their work, and so these research papers come out, which can, they're not easy to go through. And like I say, sometimes what we have found is there's small amounts of data or findings which could be a product within that paper, and it might not always be obvious. And so you have to read these things 2-3 times. So we think tech transfer then basically is this process here, right? Obviously, this is from the UK CPI. I can cite them. They actually put this diagram together. You've got the technology readiness level. This is a scale that was actually invented by NASA, the space agency. And academia basically sits at the 1, 2, 3. So that paper I showed you before basically is TRL 3, and right. So where we get involved is TRL 4, 5, and 6. Okay, the research paper basically won't have a product name, it won't really have a target market sort of defined, and it won't even maybe have a channel as to how that product will end up being commercially viable. There is an argument to also provide tech transfer for innovations around societal benefit as well. There may not always be a commercial benefit, but there may be certain research that you can create into a product that's good for the environment or good for society. So we do look at those as well. But typically we're not basically at the 1, 2, 3 level, right? It is, as a company starting with that idea. That's what the universities are built to do. And then the 4, 5, 6, we can actually work with the end users to actually develop the technology. And then obviously 7, 8, 9 onwards is where the large companies or the industries get involved. Industry will get involved in, I think, in two sort of, or industry and government will get involved in 2 ways. One is, well, once there's a product, industry will either buy it and then implement it to their customers. So there may be a large company that will buy the product, or industry will take it on, and there might be one company that's just using it just for their own internal use. That is possible as well. So it's not necessarily that you make a technology transfer that has a worldwide or multiple use appeal. It may just mean that one company or one company that's owned by a state could be using it. So there's many examples of that where technology transfer has just worked in that particular way. So I think it's important to try to understand that not everything is designed to be a huge sort of worldwide process. There are things that are very niche, very specific to a challenge statement that companies, governments, organizations need to look at and then go through this particular cycle. But the academia and like I say, the industry, they're linked by this 4, 5, 6, which we'll explain is not hard. It's not an easy place to be. So what we do, and I think generally you'll find in product design, especially around the new sort of tech era and the whole thing with AI, it being self-learning and continuously improving, is that you basically have this life cycle, this process, right? So this could be, you could put a timeline against this, which could be a matter of days through to perhaps a year. I think in the past perhaps it would have been 2-3 years. But now the way that obviously the technology is moving and the industry is moving, and again going back to the high performance compute side of things, you can model a lot more quickly to make your predictions and then to design your particular product as well. So we look at this as our sort of basic process of how we would design a product, engineer it, and then also put it into production so that it's available for the end user. Obviously the marketing side is part of the business element of technology transfer, which we won't go into today, but it's an important factor purely because that customer feedback helps you to refine the product, and perhaps even gives data back to the academics now. I think that's one thing we are discussing with one of our projects, where the academic stays in station, stays as a professor, and we can actually provide information back to them in the form of, okay, this is how your technology has worked, but it's exposed all these other particular problems, and they have actual data to work from. You have a trustworthy end user then can work as well. So there is a way that this particular model can bring in the academics, but it's something which happens over a course of time as some results start to take effect. And so, why do we choose that particular end user? We always start from the problem statement, and I think with universities now, especially, you could probably argue that some of the European ones and then maybe the American ones, because they have established structures for innovation and research grants, that perhaps they weren't using real world instances or real world issues. But now, I think with the emerging economies now coming to the market, obviously the rise of China, obviously India now as well, are emerging, and even smaller countries. We're doing stuff in Uzbekistan and Turkey. You've got places where obviously researchers are now are being utilised, I think, on a more direct and localised level as well. So, can you identify a problem that exists in that particular part of the world? There may be similarities that are in other parts of the world, but what you'll find is that one man's problem in another place, one lady's problem in one city might have a 50-60% resemblance in another one. So, it does need some localization to it. So that defining of that problem is important. And that's really, I think, where we come in as a technology transfer company. We have to take the research that might be a bit theoretical. I say a bit, it's been maybe practiced on synthetic data or a small amount of real data. And then the problem statement that we can get from the end user will have some stats behind it and actually some historical data from where the modeling can be done. So going back to the HPC, we would put the historical data in there, and we would take the research and then be able to actually see if we could actually make an impact. If we could have made an impact on that particular problem by doing different types of models. Okay. We also use a domain expert, which is somebody usually who's got some experience of working in that particular industry. Again, I won't talk about it now. It's something which is part of the process of our technology transfer, and it'll be covered in series going forward. The last point I put there is also what external sources of data can be added. The good thing with the modeling side of what high performance compute enables is when it's available is you can try different ideas. So you may have a particular problem, and simply adding weather data or simply adding macroeconomic data or microeconomic data, you might be able to find certain trends that you weren't aware of, or certain solutions, or how to solve a particular problem just by adding that piece of data to it. So it allows you to think wider, more outside the box in terms of what you can actually try out by having access to the compute power as well. These are some of the universities obviously we are talking to, and they provided us with various technologies. We've got some localized ones. We actually had Science University here earlier today. We've got University of Sharjah coming, and the American University of Sharjah as well, and also some engagement with Higher Colleges of Technology, which is a national organization for further education. So we're not limited to obviously just UK ones, but you can see obviously the phrase at the bottom. The UK does have 1% of the world's population, but generates 16% of the world's research papers. Obviously, China is increasing, India is increasing that, and so that share will go down. But nonetheless, I think per head, the UK does spend a lot in terms of research and creating a lot of the technology ideas that are available. So we do utilize a lot of that for ourselves. And so I think the point behind this is that there's a lot of technology, there's a lot of research papers out there for people to look at for technology transfer. So if you're sitting now in a government, you're sitting now in a company, and you've got a particular issue or challenge, or even just your product line, could do an enhancement, it's always worth searching. Maybe even if you do it once a quarter or twice a year, there could be a research paper out there that might be even 3, 4, 5 years old that could solve the particular challenge you may have in your company. So then these are, it's as simple as sometimes reaching out to the academic on there, see where if they're still in the position they are, they state on the paper, or find them. There could be somewhere else, but the universities are actually very open to these collaborations, more than you think they would be. And I think a lot of them are getting a lot better in terms of working with businesses, right? So you don't want them to deviate from research. Likewise, you don't want to deviate into research. But I think there's some good universities there now that are understanding that process as well, and that's helped by government, right? So as long as the national government helps on that as well and makes people understand that, then it's possible. So that's why for large companies, large enterprises, sorry, whether it be government or private sector, you should look at the university as a source of solving your particular challenge statements, or even products that will enhance your existing line. Okay, so because what technology transfer does, it essentially does contribute to the economy, right, in many different ways. First of all, obviously, in-country value. Obviously, that's taken from the UAE. So there's a policy here to drive up in-country value by developing stuff within the country. So some of that obviously being, if it's computer code that's being developed, that also creates high value jobs as well. So that's important. Obviously, you're creating that intellectual property. In essence, if you have a spin out that comes from university research, then obviously there's startups that are created, which again, you don't necessarily have to have startups that are become 10, 15, 20 or 100 people companies. The intellectual property itself becomes tradable, right? So you have the background IP that the universities obviously create, and they protect themselves. If there's a commercialization of the background IP, then that's obviously good for everybody. And then a particular company's role in that could mean that they own some of that. But there's also a foreground IP that anything developed after that is potentially 100% yours, right? And so there's obviously a bigger piece of business that could be done there. It does come with its obviously it's the TRL 4 to 6 does come with the valley of death, as they call it over there, as I've put in the presentation. But there's ways to mitigate that, which I'll mention in a second. But being able to have incubators and accelerators, just having those without universities, I think involved, I think is very difficult. If a government out there is wanting to sort of generate jobs by creating jobs or creating companies without the university input, these business ideas are going to be hard to create. You'll end up just another restaurant or another coffee shop or another lawyer's firm. All these professionals. There's no reason why a lawyer can't start a tech company if there's the right technology transfer opportunity available, right? So, and also I think sitting in Sharjah, it's a very global environment in the sense that the local government here have done a fantastic job in not just focusing on the local resources. They're very outward thinking, very welcoming as well. So as a British company, when we came here to do a tie-up, having the Dubai company do a joint venture, and then obviously working with the local government, it shows that it is possible to do, and there is support out there as long as there's a collaborative sort of effort behind that. And so that gives us an example of the type of collaborations that we're doing. If you look, obviously, the UK government have been very supportive, and they actually introduced us to the park here. Obviously, the Sharjah Research Park in this instance is a government, is a part, I think, government body. And then you've also got the technology companies, right? Intel, Lenovo, them getting they understand what tech transfer is, which is very helpful in terms of our journey and our ability to help others as well, right? So some tech transfer we're not going to get involved in, but we know we can point them towards Intel and Lenovo, who understand what the process is and how. Just to give you a very simple example of that is how converting MATLAB code to Python and then optimizing it on the CPU. It's a boring task, but it's needed to be done, right? So someone like Intel have been quite supportive on I think 2 or 3 projects that we're working on where we need that to happen. So, tech transfer, that comes into the 7, 8, 9 realm, doesn't it? So, even from a company like us, we have to look at how the product will scale up and how it will then work with end users. And people like Lenovo, for instance, they do work with obviously the big companies. They put in $200, $300, $400 million systems, don't they, across the world? So that has been helpful for us. Obviously, these companies are always open to other collaborations, or again, we're open to the idea if someone wants to work through us. We are working in Uzbekistan as well, and again, the local universities there have been very welcoming. And one thing I suppose we should sort of mention, obviously, with the tech transfer, is quite helpful in terms of talking to students and attracting talent as well. So a byproduct of maybe a research paper that doesn't get somewhere, or it might take a bit of time, that interaction with an academic who's at least got the mindset to go and transform their idea into a technology product means these are the types of guys and ladies that a company, especially maybe a startup or scale up, can use in their other work. So tech transfer has a lot of assets, a lot of risk mitigation policy, risk mitigation offsets, if you like, where you can mitigate your time that you might spend on that. The other thing is also, if you do get involved in tech transfer and you sign up and you start working on something, obviously you're reliant that the product will sell. One of the risks behind technology transfer is sometimes it could be your technology could be so disruptive that the local government, we've been in this situation, the local government may not take it on, or whichever public sector or private sector, there may be a monopoly in the private sector and they just don't want to take your product on. But I think the mitigating part of that is when you own some of the IP behind it, there's always a way to commercialize. And to give you one example, with the high performance compute, we're working on a range of different algorithms. One is for sort of crime detection. Another one is to do with genome sequencing, and we're going to cross pollinate those different technologies those different scenarios. The reason being is we don't actually know what might happen. So if you've got a situation where a certain technology, you might have spent time or some certain money in that. With the good thing with the MATLAB software program and high performance compute, you can try that technology across different applications, and you may actually find something else comes out of that. So I'm not saying you have to work with us, but if you do work on technology transfer, do bear that in mind, that even your public cloud provider will give you access to GPUs, and you can just try these many different ideas. I think even MATLAB actually have their own cloud as well. So so that's something which is definitely possible within the realms of technology transfer.
All right, thank you again, Mr. Raj, for the very wonderful presentation. And guys, I hope you learned a lot from this session. And in the upcoming webinars, we'll be tackling more on the technical side, namely data science, machine learning, AI and AI infrastructure, coding and programming, challenge statements, and value creation. So keep on the loop. Before we wrap this up, please don't forget to follow us in our social channels. You can search for us in Facebook, LinkedIn, Instagram, or Twitter by typing in hb.ai. So if you have any questions regarding today's episode, you can always message us through those same channels. So until next time, this is Mark again saying, keep innovating.